Hello everybody, this is the third clip of our chapter 3. For this one we are going to talk about the so-called the dot product, or sometimes it is a scalar product. Okay, so the dot product or the scalar product is the product between two vectors. Okay, and usually we use the small circle like this to indicate the dot product. Okay, and after you find the dot product, it becomes a real number. So, okay, it becomes one real number. So that's why sometimes we call it a scalar product, because two vectors product each other, and then the result is a scalar. Okay, so it's just a number without any direction. So let's see what is the definition of the dot product. If you have your vector A as a1, a2, a3, and the vector B as b1, b2, b3, then the a dot B is simply a1, b1, a2, b2, a3, b3, and then you add them up. So it's simply the first component product, the second component product, and the third component product, and you just add them up. Okay, that's it. Very simple. Okay, so one of the property is that if you got the A and the A, so it means that your A dot A is simply A1 square, A2 square, and A3 square, and it is look like a square root of this one square again. So it's simply the length of the A square. Okay, so it's the length without the square root. And because the dot product consists of a product of numbers and also the addition of numbers, then you can do either A dot B or B dot A, they'll be the same. Okay, and if you got A and then dot B plus C, you can also do a distribution, look like a usual multiplication in terms of real number. Okay, so you got A dot B and A dot C added together. If you have a scalar C multiplied by A and then dot the vector B, you can either do the C and A first, or you do A dot B first and then multiply by a number C, or you can just do the C multiplied by B and dot the vector A. Okay, it doesn't matter, you can do any switching of the order like this. And if your vector 0 dot with vector A, the result will be just a real number 0. Okay, so look at it carefully, which one is the vector, which one is a number. All right, now we got another formula for the A dot B. Okay, so it's saying that your A dot B is actually the length of A, the length of B multiplied by a cosine theta, and the cosine theta is always the smaller angle between A and B. For example, here this one is the angle between A and B. We are not going to talk about this angle. Okay, so always a smaller one. Okay, this one as well, the angle between A and B, the small one. Okay, and if you want to find the angle between two vectors, it depends on this cosine theta, and you just simply do the A dot B divided by the length of A and the length of B. So of course, I mean, because you need to do a division, then your A and B cannot be zero vector. Okay, and we can say that your A and your B are orthogonal if and only if your A dot B equals to 0. Why is that? Don't forget that the word orthogonal means perpendicular again. So if your A is perpendicular to your B, so it means that the angle between them is a 90 degree, or a pi over 2. So it means that your A, in this case, your A dot B, it is the length of A, the length of B, and then cosine of pi over 2, and the cosine of pi over 2 always 0. So you got a dot b equals to 0. Okay, so this is the relation of the a dot b with the 0. So if this one is the acute angle less than 90, then a dot b it is positive because your cosine is positive. If it is the right angle, your a dot b is simply 0. And if your angle is greater than 90 degree, okay, then your cosine is a negative, so a dot b becomes a negative as well. Okay, so we have two formula for a dot b. Okay, the first one is just simply each component multiply, right, and then you add them up, and the second one is the one that consists of cosine. Okay, the length of a, the length of b, and the cosine. Now we are going to talk about the so-called directional angles and the cosine of the vector a. Okay, so let's say that your a is a non-zero vector. The directional angles of a non-zero vector a is the angle alpha, beta, and gamma, okay, in this interval 0 to pi, okay, such that actually the cosine alpha is the a. Okay, this is a component, the first component, right? So your a is a1, a2, a3. So it is the first component divided by the length of a. Okay, the cosine beta is your second component divided by the length of a, and the cosine gamma is the third component divided by the length of a. Okay, and this one is so-called the directional angles, the directional angle. Okay, and another thing that you may need to know is the so-called scalar protection. Okay, a scalar protection. So let's say that here we got the vector a, okay, just like this, and the vector b, and then it seems that you got the light, okay, shining from here. Then here this one is the shadow that your b cast on a, right? So this is the right angle, and this one is simply a right triangle. Okay, what we need to find is this length over here first. Okay, so the length over here is a so-called scalar protection because it's only the length, okay, has no direction. All right, so if this is the angle theta between a and b, then look at this right triangle. Let's say that the length that we would like to find is the length of x. Okay, this is the length, okay, we call it x. So we know that this one, the x over b is a what? Okay, here is the adjacent over the hypotenuse, right? Okay, it is a what? Cosine of theta. So your x is actually the length of b and cosine theta. However, previously we know that the a dot b, it is simply the length of a, the length of b, cosine theta. So if you need the cosine theta itself, okay, in order to plug in here, then it just simply a dot b over these two lengths, right? So this one you can just simply saying that the length of b we just copy, okay, and the cosine it is a dot b over the length of a and the length of b. So the length of b cancelled, so it means that this one becomes a dot b over A itself. Okay, A dot B over A itself. So this one is so-called a scalar projection. You see, scalar projection. All right. So it depends on you guys whether you guys will remember the formula or you will look at it as a picture like this. If you want to remember a formula, then I have one thing that I'm not so sure. This is the way I remember. When we talk about the shadow of B on cast on A, so the word on, it means that your A will be the one at the bottom, and then on the top you just finding the A dot B. Okay, so that's why we call the shadow of B on the vector A. That is a scalar projection. The next one that we are going to find is the so-called a vector projection. So when we talk about a vector, what does this mean? It means that we need also not only the length, okay, this one is the length, right, but also the direction. So from the picture we know that the direction of this projection is the same direction as A. So how can we find this one? How can we find this one? So the projection is actually the vector that has the same direction as A, but the length of x. So it is the unit vector of A, right? This is a unit vector of A multiplied by the new length that we need. Okay, so the new length that we need, it just calculated by this one. You see, this is the x, and then you multiply further by one more length of A to find the unit vector. So this is a square, and then multiply the whole thing by vector A. So don't forget that this quantity is a number. Okay, so it's a scalar multiplied with a vector. This one is so-called a vector projection. Yeah, vector projection. So to me, if you want to remember, I mean, if you understand that, that will be better, of course, right? But if you want to remember, then I usually remember this length, and then to find the vector projection, it's look like I multiply the A on the top and the A at the bottom. However, to let your vector A becomes the one at the bottom, you just need to change into the length, okay? Because your A cannot, I mean, the vector cannot be divided. I mean, the vector A cannot the one at the bottom. So the only thing that can do as a division is the length of A. Okay, so it depends on you guys whether you will try to understand this diagram or you remember. But if you need to remember, please do it correctly. Okay, so this was a B onto A. It'll look like this. So of course, I mean, you may think of it by yourself. If we change like A onto B, then what will be your scalar projection? What will be your vector projection? Okay, which one will be changed? Okay, so let's see. You need to find the dot product between two vectors. Okay, if the lengths are 6 and 103 and the angle between them is pi of 4, so this means that one of them is 1/3. Let's say this is 1/3, this is 6, and then the angle between is a power 4. So let's say this is a u, this is the v. So the u dot the v is simply the length of u, the length of v, and then cosine of power 4. So the length of u is a 6, the length of v is 1/3, and then the cosine is a square root of 2 over 2. So you got square root of 2 out of it. Okay. Now, I mean, if you need to show that all these are equals to 0, actually it is very simple, because don't forget that your I actually is the unit vector along the x-axis. Okay, this is the I, and then your j is a unit vector along the y-axis. So what is it? They are perpendicular or orthogonal to each other. So of course the dot product must be 0. And if you look at the k, which is the one unit vector along the z direction, so it will orthogonal to j and of course orthogonal to I. So they are all 0 as you find a dot product. And then because each of them are unit, okay, they are unit vector. So what does this mean? It means that your length always 1. So it means that if you want to find the I dot I, it is the length of I square. So it is just 1 square, which is always 1. Okay, so this is very simple. If you want to find the angle between these two vectors, so let's call this one as A, this was B. So you know that the A dot B, it is the length of A, the length of B, cosine of the angle between them. So the A dot B, it is 1 and 4, 2 and 0, 3 and -1. The length of A, the square root. Don't forget the square root, okay? The first component square, the second component square, and the third component square. So this one as well. So you got something like this with the cosine theta. So it means that your cosine theta, it is this quantity, which is 4, -3, so it is 1. And then the square root of 9, 1, so it's a 14. This one is 16 and 1, so it's a square root of 17. So it means that your theta is the arc cosine of 1 over square root 14 and the square root of 17. Okay, something like this. If I mean, you can just stop it like this one, or if you have your calculator, you can punch your calculator to get the arc cosine of this quantity. Okay, that will be also good as well. Okay, but it is good enough to stop right here. Okay, now if you want to use the vectors to design whether the triangle with these 3 vertices are right angle, so what is it that you need to do? You can, I mean, from these 3 vertices, you can find the vector PQ, you can find the vector PR, and you can find a vector QR, right? So that it will be the triangle. So this one is a Q minus P, so it is 2 and 1, 0 and -3, and -4 and -2. So it becomes a 1, a 3, and a -2. How about a P and R? So it is a R minus P. So you are 6 and P, -2 and -3, -5 and -2. So it becomes a 5, a 1 and a -3. And this one is a R minus Q. So your R is 6, your Q is 2, -2 and 0, and -4. Sorry, your R first. So -5 and minus -4. So you have 4, -2, -1. Okay, and what you are going to find is to check the dot product between them. Okay, so for example, the PQ and PR, okay, these two, so you got 1 and 5, you got 3 and 1, and you got -2 and -3, so you have 5, 8, and -6, so you have 2, it is not 0, so they are not perpendicular to each other. How about PQ and QR? So your PQ is 1, QR is 4, 3, -2, and the third component, -2, -1. So you got a 4 minus 6, so -2, and then you got another 2, so it is 0. So here your PQ, it is perpendicular to your QR, or it is orthogonal. Okay, so this one we can design that it is really a right triangle. So let's say that this is roughly speaking, okay, P, Q, and R, just like this. So your PQ, your PR, this is not a right triangle, but your PQ and the QR, it is a right triangle. So let me just draw it like this. This is a Q, and this one, your QR, here is a right angle over there. Okay, next, what if you need to find the value of B that make these two vectors becomes orthogonal? So orthogonal, it means that your two vectors dotted together must be 0. Okay, so this one you got a -6b, you got a b cubed, because when you dotted, it means that your each component multiply, and then you got 2b, make it equals to 0, or you got b cubed minus 4b equals to 0. So here you have this one, so it means that your b can be 0 and 2 and -2. Okay, that will make these two vectors orthogonal, right? Okay, now you need to find a scalar projection of a b onto A when your A is this one and your B is I minus K. Okay, so let us recall a scalar projection of B onto A. So as I told you, it is A dot B over the length of A. So this one is the length, and then because you need it to be a vector projection, you are going to multiply it by the vector A itself and then divided by the vector A, but because it is a division, you need it to be the length. Okay, so everything is all set. So your A, it is a 1 1 0, your B, it is a 1 0 -1, and then the length of A, it is a square root of 1 square 1 square 0 square, and the A itself, of course this is another square, right? Don't forget. And then the A, it is 1 1 0. So the one on top you got 1, and then the rest are 0. So you got 1 on the top, and then you got a square root of 2 square, so you got a 2 at the bottom, and this one is your A. So that will be your vector projection of your B onto A. Okay, you may try to do it by yourself if you need to find the vector projection of your A over your B. Okay, what will be changed? Okay, let's try. We okay on this problem? All right. For the rest of the problem, we are not going to do it, to the complete of the problem, okay, but we are going to just explain like how to do, and then we'll let you do it by yourself. For example, if you really need to find the dot product between R minus A and R minus B, they are all vectors, right? So actually you can do the R minus A, okay, dot r minus a dot b, just like this. So you got the r dot r minus the a dot r minus your r dot b, and then plus your a dot b, and don't forget that the right hand side it is equals to 0. So here the r dot r, it is simply your length of r square. So it is x square, y square, and z square. And for this one, okay, actually you can look at it as the minus your r dotted by the a plus b. So you do the a plus b first. So you have a1, b1, a2, b2, a3, b3, and then dot by the r. Okay, you see this one, we just pull out the negative sign over here, so it becomes a positive, and plus your a dot b, okay, which is of course the a1 b1, a2 b2, a3 b3 added together, make it equals to 0. So this one, it is x square, y square, z square, and then minus by the first one as a1 and b1 multiplied by x, a2 and b2 multiplied by y, and a3 and b3 multiplied by z, and then plus the rest of the company, or this. Okay, so what you need to do, okay, to continue this problem is that you are going to change this one into the form of x minus h square, y minus k square, and z minus l square equals to r square, in order to make it represent a sphere. Okay, so you are going to look at the x square, the one with x, and the numbers, okay, to make it to be the completed square, and the y square with the y, the z square with the z. Okay, so if you want, then you can continue this problem by using the completed square. Okay, how about this one? You need, if we want to find the angle between the diagonal of the cube and one of the edges, okay, so can you represent the problem like this? If this is your z, this is your x, this is your y. So the cube, it means that each of the side of the box will be the same, right? So let me try to draw a good cube. Okay, has the same size. And then when we talk about the diagonal, okay, I'm sorry if it's not that good drawing. This is the diagonal. Okay, so what is this one here? So let's say that here, I mean, each of the side has length of 1. So this is simply 1, 0, 0, right? How about this one? This one, your x is 0 and your y is 1, your z is 1. So can you find this vector here? And then one of the edges, so let's see the one edge that it is very simple, maybe this one. Okay, you can choose any other, okay, because it's already there as the same initial. How about this terminal 1? The terminal 1 is 1, 1, 0. So can you find this vector v? So if you can find vector u and vector v, then the u dot v, it is the length of u, the length of v, and then cosine theta, and you can find the angle between these two vectors using this formula. Very simple. Okay, we're going to stop this video clip right here, and then for the next clip we are going to study about the so-called cross product or the vector product. Okay, so this one, the product between two vectors become a scalar or a real number, but the next one, the product between two vectors becomes a vector. Okay, we'll see you then. Bye bye.